Welcome back to another video. This one is going to cover square roots, cubed roots, and exponents. And if you thought the puns last year were bad, this year I actually got Mrs. A interested in puns as well. So you're going to get twice as many good ones because they're not just from me anymore. So I'm very excited about that. This topic is going to cover something that you've probably seen in 7th grade, but this is coming from the perspective on 8th grade, as if we've seen it before. So this should go pretty quick, and it should be mostly review for us. So if we start with exponents, now I just did squares and cubes, but exponents could be anything. You could have 1 to the 6th and 2 to the 8th. Your exponent can be any whole number. That will not be a problem at all. But for the sake of this video, I kept it to squares and cubes. So for the first slide, we did squared numbers. And if we talk about what 1 squared means, 1 squared, if this is the base, just means that it's 1 times 1 twice. Therefore, 1 times 1 is simply 1. 1 cubed would be the same process as 1 times 1 times 1 again, which is still 1. In fact, anything raised, 1 raised to any power, is actually still going to be 1, and that will only be true for the base of 1. Now, when we start working with bigger numbers, the process is going to stay relatively the same. 2 squared is simply 2 times 2, which is equal to 4, and 2 cubed would be 2 3 times multiplied together, which is 2 times 2, which is 4, times 2, which is 8. In fact, if we take this number times 2 again, it would give us the next. So 2 to the 4th would be 8 times 2, which would be 16. That process will continue forever. 3 squared, which is 3 times 3, is 9. And 3 cubed is 3 times 3 times 3, which will be 9 times 3, which is 27. What I want you to do in your notes is to make these two charts all the way down to 13 squared. And on this side, I want you to be to 10 cubed. And those are the numbers that I expect you to have memorized. Anything above that, we would then work out by hand. But I want you to have 2 13 squared and 10 cubed memorized. Now, square roots, are the opposite of squared. And then cubed roots would be the opposite of cubed. So if 3 squared is equal to 9, that means the square root of 9 would be equal to 3. And this is what we call the positive root. Basically, it means that 3 squared is equal to the base of the square root. Now, if they're ever asking for a number that is the negative root, that will be, in this case, negative 3. And the reason for that is if we did negative 3 squared, we still get 9. In math, we will almost always work with the positive root, but if it ever wants a negative root, it's usually just a negative number of whatever the positive root would be. So let's start working on a few more. If 4 squared is equal to 16, the square root of 16 better be 4. And if 6 squared is equal to 36, the square root of 36 better be 6, because 6 squared is equal to the base of the square root. So if you are good at exponents, you are usually good at square roots as well. Now, these are only what we call perfect squares. If you get a number that is not a perfect square underneath the square root, you end up creating what we call an irrational number. In this section, if you start working with irrational numbers, you have to estimate them, but we are not going to cover that in this video. Let's move to some cubed roots, which once again will be the opposite of perfect cubes. Okay? If 3 cubed, that's 3 times 3 times 3, is equal to 27, the cubed root, which you notice there's a little 3 up here, that means cubed root, will be equal to 3. And if 5 cubed is equal to 125, that's 5 times 5 times 5, the cubed root of 125 is positive 5. Now, because these are cubed roots, and this is an exponent of 3, negative 3 cubed is not equal to 27. It's actually equal to negative 27. So there are no positive and negative cubed roots. Your only answer is just 3 or 5. Now moving down to a tougher one, 2 to the 4th. That is 2 times 2 times 2 times 2, or 4 times 4. So this is 16. We then say the 4th root of 16 would be equal to 2. And that's how that works. That can go up infinitely. But in math, you almost always work with cubed roots or squared roots. But you can have 4th roots, 5th roots, 6th roots, all the way up to any number. Whoops, I didn't mean to do that. Okay, and now we're going to go to the last side. And this is what like a level 4 type problem would be in this section. We are solving for the variable or solving the expression if we're given the variable. For the top one, we have the square root of 25 minus 9. If we're ever working with square roots, we want to pretend there are parentheses underneath the square root. So you will do whatever you can underneath the square root first and then solve for the variable second. If I notice that 25 minus 9 is actually 16, now there's nothing else we can do underneath the square root. Therefore, we just simply solve for x, which is 4. Because if 25 minus 9 is equal to the square root of 16, then x has to be 4. Down here on the bottom, if y is equal to positive 4, we are going to plug in positive 4 right here. So we end up getting 16 times 4. Once again, we want to pretend there are parentheses around these numbers. 16 times 4, that would be 16 times 2, which is 32. Then times 2 again. So you get the square root of 64. And 8 times 8 is 64. Therefore, the square root of 64 is positive 8. And finally, the last problem. Square root of 5 times 5 equals a. Well, 5 times 5, that's 25. And that equals a. And the square root of 25 is equal to a positive 5. So we have solved it. So we gave you a brief overview of all of these topics. As always, if you have any questions, make sure you ask me as soon as possible.